By now we know the transverse shear stress equation for tau VQ over IT, and we set Q equal to integral of y to C I dA apostrophe. So we want to know what is Q in that first introduced in this class. So let's call that Q is, for this class we call that Q is the first moment of outward area. And as said earlier, I have Q equal to integral of y to C y dA apostrophe. So why they call it the first moment? Because as you can see of the area, so y, the distance, perpendicular distance, time the areas, that's why first moment. Outward, y to C. So from that here, the section we cut here, as you can see, from the lower portion, lower section of that differential slide dx, section dx. So as you can see, we only count from the y position with the black to the outermost fiber, which is C. That's why we call it outward areas. Outward areas. That's why here they call the first moment of outward areas. Integral, no one want to do integral. Then here, if normally we deal with the cross section with the regular shape, rectangle, Y flank shape, I shape, or we have even trapezoidal shape. All of that shape is considered standard shape we can use. And with that, for regular shape, how can we find out Q? As we don't want to deal with the integral. So regular shape. For regular shape, what do I have for Q? Q equal to sum of all that shape, all standard shape, right? All regular shape, y bar to A apostrophe. So instead of integral, we just break it down that shape into some regular standard shape that we have, and then we can find out the sum. That's much easier than take the integral. So let's define what is A apostrophe in that equation, and what is y bar, what I mean in regular shape with that. So, and very important, you need to understand what is all of this terminology so that we can apply correctly. So what is A apostrophe? That is outward area. So white outward is from point of interest to outermost fiber, in here to outer edge. Outward area from the point of interest. In this case, the point that we have is y from the neutral axis to the outer edge, outermost fiber C. How about y bar? Y bar is the distance from the neutral axis to the centroid of the outward area. The distance from neutral axis to the centroid. Keep in mind that very important, to the centroid of outward areas. And normally I see many people confused with finding. So the most challenge that I can see is how to find out the Q so that we can apply the VQ over IT equal to the tau, the shear stress. So the most challenge is the Q. So keep in mind this definition is very important. So what is Y bar? Distance from the neutral axis to the center of outward area. It's not Y as we defined earlier. Okay, the Y is from the neutral axis to the point of interest. Now Y bar, where is Y bar? Let's draw it down here. Y bar. Let's make a different color that we have here. So Y bar from the neutral, the distance from the neutral axis to the centroid there of the outward area. So to that point, and that is Y bar. So you see that the difference between the Y and Y bar, very important. The Y is from the neutral axis to the point of interest with the black surface that I cut. And Y bar is from the neutral axis, also from the neutral axis like Y, but go to the centroid of the outward areas. So Y bar and Y are not the same. Keep that in mind in that definition. Now, with that, go back to look at the equation of Y bar A apostrophe. So as you can see, Q here is Y bar A apostrophe. So basically, the A equal to the width of the beam times whatever the function with the Y from the neutral axis times the Y bar also depends on the Y from the neutral axis to the point of interest. So if we look at the math that I'm not going to go into detail, but actually Q is a function of Y, but it's in square. So what does that mean? It Q basically vary parabolically in the members with the constant width. If we have a constant width like same rectangle square for the rectangle for the cross section, then the Q basically vary parabolically. And when the Q vary parabolically, as you can see here, V with one cross section, V the same, I of course the same based on our assumption that prismatic, T if that one point the same, then it tau varies based on the Q. At Q it vary parabolically, the transverse shear stress vary parabolically about the neutral axis, because the first moment of outward area Q also vary parabolically. So bottom line, in order to find Q, you must be able to find the neutral axis, because that's where we define the A apostrophe and Y bar, always derived from the neutral axis. The bottom line, Q vary parabolically, and the tau, the transverse shear stress, also vary parabolically. So with that, why we have all of that, and I can remind, if you forget all of that note, you can go to the study guide of today's class. We have all of that there. You see, you should understand the limitation of shear stress equation with the four assumptions that we have, and the transverse shear stress vary parabolically about the neutral axis. And also, you to have all of this, you need to know where is the location of the neutral axis before we can start. And similar to others problem, we also have the home study problem. It's very important, and for this today class, and we will move on to apply for the design beam with consider both moment and shears. So with that, we have done for this class, and go to practice the problems for today.